half angles. All right, now let's think about this. So what do I want here? For example, I want to know how to deal with sine of theta halves, right? So sine of theta halves. How am I going to be able to do this? Well, check this out. This is kind of clever. If I think of sine squared, now wait, let's back up. I want to be real sure that we understand something first. This theta is a known amount. It's something that we can wrap our brains around, even though down the road it may be represented algebraically. But what we like is theta. And I want theta halves to go away somehow and be able to pop this thing into theta. Well, let me show you how clever this is based on the formulas that we just created. Let's write sine squared theta again. I know that this becomes 1 minus cos 2 theta all over 2 from that last formula. Now, what do you notice is the relationship between this angle and this angle? It's double. This guy right here is twice what this guy is. So if I start with a sine of theta halves in this formula, right? Remember, this is just an angle measure. It doesn't matter what I name it. I can name it alpha, beta, theta halves, theta 96th. Who cares? I can name it Tom if I want, although that's not always very helpful, especially those other people named Tom. What I want to be able to do is I want to be able to get rid of the theta halves and get it back in terms of theta. Now look at the relationship. If I start as a theta, this ends up being double what I started with. So if I start with theta halves, watch. If I take sine squared theta halves, remember, I can plug anything into this. It's just an angle measure. Do you agree I would get 1 minus the cosine of, well, again, this angle is twice this angle. So twice theta halves is theta over 2, which implies that sine of theta halves is equal to plus or minus the square root of 1 minus cos theta over 2. Now, this plus and minus right here, it's probably the bane of many students. This is determined by the quadrant. And I'll give you a few examples of that and you'll understand. So this is determined by the quadrant, by quad. Okay? So, as promised, let's figure out, just for fun, let's figure out what the sine of pi eighths is. All right? Well, all that I have to recognize with this is that I'm taking the sine of pi fourths and cutting it in half. And now I have a half angle. Now let's think about this. According to this is equal to the square root. We'll deal with the plus and minus sign in just a sec, of 1 minus cosine of pi fourths, right? Because twice pi fourths, or pi eighths, which is pi 4 halves, is just pi fourths. And look at that. I now have a value that I'm very comfortable with. See how that works out? And this ends up being, let's see, the square root. Oh, wait. We have to address the plus or minus. Well, where's theta? It's in the first quadrant, right? So again, I'm always using all students take calculus. I'm in the first quadrant, everything's positive, so it's just positive. So this ends up being 1 minus root 2 halves over 2, which is just ugly, isn't it? But so we got to clean this up just a little bit to keep ourselves from going crazy. This is going to end up being what? 2 minus root 2 over 2 over 2. Egad. So this ends up being the square root of 2 minus root 2 over 4. I can clean that up because the quotient of square roots is the square root of the quotient, so I end up with 2 minus root 2 halves. And that's what it is. If you plug it in your calculator, you get the same thing. Let's do exactly the same trick, but let's do it with cosine squared theta halves. Now again, keep your eye on the prize here. I want to be able to get rid of this theta halves and get the thing back in terms of theta. Okay, so cos squared theta halves, ends up being, well, let's think. I know, let's write over here, I know that cos squared theta is equal to 1 plus cos 2 theta over 2. Again, the relationship between these two angles is that they're doubled. So if I start with cos squared theta halves, won't I get 1 plus cos theta? This is twice that, divided by 2. So cosine squared theta halves is equal to plus or minus the square root of 1 plus cos theta all over 2. Same trick. It's exact. Look at it. They look almost identical. The only difference between them is this one's got a minus, it's got a plus. Okay? Now, again, you don't have to memorize those, but you better, like on your formula sheet, you better have them highlighted with fireworks shooting out of them, and things of that nature. That said, watch how easy tan of theta halves is. Well, tan of theta halves is sine of theta halves over cos of theta halves, right? And then I just plug and chug. I end up with plus or minus the square root of 1 minus cos theta over 2 over plus or minus the square root of, I don't know what's going on there, 1 plus cos theta over 2. I can split everything up into square roots. These square roots of 2 end up canceling out, and I end up with plus or minus, the square root, I just burped, 1 minus cos theta and 1 plus cos theta. All right, and that plus and minus is determined by the angle, or by the quadrant. All right, now, let's play with what I mean by that. Let's do one of these problems. Let's say that, just for giggles, let's say that the sine of alpha, let's go sine of alpha, I love it, is, let's set it equal to 1/3. And I'm going to say that tan of theta is less than 0. All right? So let's find sine of, let's go alpha halves. Just throwing a few things out here. Let's find cosine of 2 alpha. And then let's find, let's just do those two. I think that's plenty. Okay? So first things first. Let's just think about this. What's the first thing that we want to do? We want to establish a quadrant where we start. Well, if sine is positive, I got all students take calculus. All right? If sine is positive, it's either in the first or second quadrant. Tangent's negative, and everything's everything's positive in the first quadrant. So we have to be playing ball in the second quadrant. So when I do these, I always start by identifying which quadrant I'm in. So that's in that obnoxious way. Okay? Now, let's look at the formulas that we're going to need. I know, I'm just going to sort of write those. I don't want to run out of space on this, so I'm going to write the formulas that I'm going to need over here. All right, so let's see. I know that sine of alpha halves, if I use this formula, is just sitting right there. True? Cosine of 2 theta, let's see, what was that? That was cos squared, well, this is 2 alpha, of course, so it's going to be cos squared alpha minus sine squared alpha. So in the back of my head, I have this going on, right? Okay, so let's figure this out. First things first, this has a cos and a sine of alpha in it. I already know what the sine of alpha is. This has a cos of alpha. I need just a regular old cosine of alpha, don't I? Well, if I know what sine of alpha is and I know what quadrant I'm in, can't I just use the Pythagorean identity that says that sine squared, I know that sine squared alpha plus cos squared alpha equals 1. So in a puff of algebra, sine alpha is 1/3, so sine squared is 1/9, plus cos squared alpha equals 1. Which implies, oh wow, I've really got myself in a space quandary here, don't I? Which implies that cos squared alpha equals 8/9, because 1 minus 1/9 is 8/9. I know that the cosine of alpha is equal to, all I'm going to do is take the square root of both sides, and I'm going to get 2 root 2 thirds. But the question is, that should be a plus or a minus. Which quadrant am I in? Well, we already identified the quadrant, which is nice. I'm in the second quadrant. So I know this is negative. Now watch, all I have to do is follow the formulas. This is the coolest part. I know that sine of alpha halves, that's supposed to be 2 by the way, I know that sine of alpha halves is just this guy. So, you ready? Now this is going to require some thought. We're going to have to deal with those negatives, right? Respect thy negative. I'm going to ignore the plus and minus for just a minute. All right, but I'm going to go, let's see, 1 minus the cosine of alpha. Well, here's the cosine of alpha right over here. So it's 1 minus negative 2 root 2 thirds divided by 2. Here's the question. What quadrant am I in? If alpha is in the second quadrant and I have it, all right? If I take half of alpha, well, if I'm in the second quadrant, don't I know that alpha lives between, pi halves and pi, right? So if I have that, then don't I know that alpha lives between pi fourths and pi halves? Look at that. I'm in the first quadrant. Alpha halves is in the first quadrant. So I know that I'm positive, because everything's positive in the first quadrant. So this one's done. That's fantastic. So let's see, what do I end up with? The square root of 1 plus 2 root 2 thirds over 2. Now, I'm not going to bore you with the algebra. We'll do a whole bunch of this. I find my common denominator of 3, and then I multiply by 6, etc., etc. Let's do cosine of 2 alpha. Now, let's do exactly the same process. Let's use our brains. Let me change color so we know what we're doing. Watch. If alpha is between pi halves and pi, then 2 alpha is between what and what? Well, it's between pi and 2 pi. Ah, crap. If it's between pi and 2 pi, I don't know if it's in the third or the fourth quadrant. However, have no fear. Let's just watch what happens with the numbers and see if it plays out. Because notice, cosine of 2, whoa, you guys got to yell at me when oh wait, you can't yell at me. This is supposed to be 2 alpha, right? I just forgot to write the 2. Crud. Holy smokes, Ripley, use the rubber end of the stylus, would you? Cosine of 2 alpha. 2 alpha. Oops, that's all right, I'll edit it out if I have to. Right, so now I have this formula and I have this problem. Notice, this formula has no square roots in it. So the plus or the minus value is going to take care of itself. That's the best part. All right, so watch. We're going to follow it. Cos squared alpha is 8 ninths. It's going to be 8 ninths minus sine squared alpha. Well, sine of alpha is 1/3. Sine squared is 1/9, right? So minus 1/9. We've got to be real careful. Make sure you're paying attention to your signs, right? Excuse me. And this equals cos 2 alpha. All I did was follow the end of my nose. That's the best part. Last I checked, 8 minus 1 is 7 ninths, which is the cosine of 2 alpha. Now, the question is, look at this. What quadrant did we end up being in? If the cosine of 2 alpha equals 7 ninths, doesn't that imply that the cosine of an angle is positive? Well, this told us that we were going to be either in the third or the fourth quadrant, but since I'm positive, I actually end up in the fourth quadrant. It's a really good habit, you guys, to run through that mental exercise. What quadrant am I in? What quadrant did I start in? Where am I? It's nice. You orient yourself really nicely to it. Okay? Well, I hope that was useful and helpful. We are going to do a lot more of these in class. We'll do a ton of them. So get you used to it. I think they're pretty fun, and they're a good mental exercise as well. All right? Have a really good day, and I will see you